In our other videos, and as always, there'll be links below if you want to check those out, we showed you how to initialize and fine-tune a transformer model in TensorFlow. So the question now is, what can we do with a model after we train it? The obvious thing to try is to use it to get predictions for new data, so let's see how to do that. Again, if you're familiar with Keras, the good news is that because these are just standard Keras models, we can use the standard Keras predict method, as shown here. You simply pass in tokenized text to this method, like you'd get from a tokenizer, and you get your results. Our models can output several different things, depending on the options you set, but most of the time the thing you want is the output logits. If you haven't come across them before, logits, sometimes pronounced logits because no one's sure, are the outputs of the last layer of the network, because before a softmax has been applied. So if you want to turn the logits into the model's probability outputs, you just apply a softmax, like so. What if we want to turn those probabilities into class predictions? Again, it's very straightforward. We just pick the biggest probability for each output. And you can get that immediately with the argmax function. Argmax will return the index of the largest probability in each row, which means that we'll get a vector of integers. So 0 if the largest probability was in the 0th position, 1 in the first position, and so on. So these are our class predictions, indicating class 0, class 1, and so on. In fact, if class predictions are all you want, you can skip the softmax step entirely, because the largest logit will always be the largest probability as well. So if probabilities and class predictions are all you want, then you've seen everything you need at this point. But if you're interested in benchmarking your model or using it for research, you might want to delve deeper into the results you get. And one way to do that is to compute some metrics for the model's predictions. If you're following along with our datasets and fine-tuning videos, we got our data from the MRPC dataset, which is part of the BLUE benchmark. Each of the BLUE datasets, as well as many other datasets in our datasets hub, has some predefined metrics, and we can load them easily with the dataset's load metric function. For the MRPC dataset, the built-in metrics are accuracy, which just measures the percentage of the time the model's prediction was correct, and the F1 score, which is a slightly more complex measure that measures how well the model trades off precision and recall. To compute those metrics to benchmark our model, we just pass them the model's predictions and the ground truth labels, and we get our results in a straightforward Python dict. If you're familiar with Keras though, you might notice that this is a slightly weird way to compute metrics, because we're only computing metrics at the very end of training. But in Keras you have this built-in ability to compute a wide range of metrics on the fly while you're training, which gives you a very useful insight into how training is going. So if you want to use built-in metrics, it's very straightforward, and you use the standard Keras approach again. You just pass a metric argument to the compile method. As with things like loss and optimizer, you can specify the metrics you want by string, or you can import the actual metric objects and pass specific arguments to them. But note that unlike loss and accuracy, you have to supply metrics as a list, even if there's only one metric you want. Once a model has been compiled with a metric, it will report that metric for training, validation, and predictions, assuming there are labels passed to the predictions. You can even write your own metric classes. Although this is a bit beyond the scope of this course, I'll link to the relevant TF docs below, because it can be very handy if you want a metric that isn't supported by default in Keras, such as the F1 score.